This next video focuses on mesh or loop current analysis, exploring a circuit comprising a voltage source, an independent current source, and three interconnected resistors denoted as R1, R2, and R3. So let's check the given circuit. First thing to do is designate points in the given circuit, A, B, C, D, E, F. And also we designate current flowing to R2 as IL. Then, we can now proceed, draw a loop or mesh at points A, B, E, F. This loop will be assumed in clockwise direction and will be designated as loop 1 or I1. We also assigned the polarity of this loop as from positive to negative. Then, we also have to draw a loop here at points C, B, E, D. This will be our loop 2 or I2. It will be in a counterclockwise direction, which is in the same direction with the independent current source. The assigned polarity of this loop is from positive to negative. The next step is to use KVL or Kirchhoff voltage law at point A, B, E, F. The summation of voltage at point A, B, E, F will be equal to 0. We start at the voltage source. It will be written as plus 50. Since when you are writing KVL, the polarity will be based on the ending polarity of the component. And since the loop is clockwise and the ending polarity of the voltage is positive, then, it will be written as plus 50. And for the voltage drop across R1 and R2 with respect to I1, will be written as minus I1 open and close parenthesis R1 plus R2. It is negative since the ending polarity of loop 1 is negative. Then lastly, the voltage drop across R2 with respect to loop 2, will be written as minus I2 times R2. It is also negative since the ending polarity of I2 is also negative. So our equation will be plus 50 minus I1 open and close parenthesis R1 plus R2, minus I2 R2 equal to 0. Using the values, we have plus 50 minus I1 open and close parenthesis 10 plus 2, minus I2 times 2 equal to 0. Simplifying the equation, we have 50 minus 12 I1 minus 2 I2 equal to 0. Minus 12 I1 is equal to 2 I2 minus 50. Removing the negative. 12 I1 is equal to negative 2 I2 plus 50. Or 12 I1 is equal to 50 minus 2 I2. Dividing both sides by 12. I1 is equal to 50 minus 2 I2 all over 12. This will serve as our equation 1. Moving on to KVL at loop 2, points B, C, D, E. It's observed that I2 is already given as 6 amperes. Substituting value of I2 to equation 1. I1 is equal to 50 minus 2 times 6 all over 12. 50 minus 12 all over 12. 38 over 12. So I1 is equal to 3.17 amperes. Since we designate current flowing to R2 as IL. To solve for IL we will have to add I1 and I2 algebraically, and since they have the same direction, IL is equal to I1 plus I2. Using the values, IL is equal to 3.17 plus 6, that will result in 9.17 amperes. The voltage at R2 will be VL is equal to IL times R2. Plugging in the values, VL is equal to 9.17 times 2, which is equal to 18.34 volts. Finally, by sequentially applying KVL and manipulating the equations, we've determined the current flowing through R2, which is IL, and the voltage across it, VL, in the circuit analysis using loop or mesh current equations.